Okay, continuing on again. In this section, it seems not much difference. The only difference would be if you are integrating, wait a minute, I can't seem to integrate the x dy, and then you switch the order. And since it's a rectangle, it really makes no difference. And the reason for that, if you run vertical first, well, that's top minus bottom, that's a constant. And then you run right to left, right minus left is a constant. In the next section, that's going to make a difference because the region will be general region. So in this case, x runs from 1 to 5 and y run from 2 to 3. So there. And the insidemost integral is x. That's really x squared over 2y evaluated from 1 to 5. That is 1 over 2y into 25 minus 1. So I got this to be 24 over 2, right? I got this to be a 12 over y, and I'm going to integrate that from 2 to 3 with respect to y. Okay, I wrote the x twice there. Look at that. And that would be 12 natural log of absolute value of y evaluated from 2 to 3. That is 12 into natural log of 3 minus natural log of 2. Again, that is a fine answer. Most likely, the author loves this part. The back of the book will have a 12 natural log of 3 divided by 2. You really don't have to do that, but you should be able to. But for a test, no worries. And if I'm looking at this problem, okay, now if I choose x first, can you see what's going to happen when I integrate this? If I put an x first, do you see I need integration by parts? But if I do a y first, so why don't I switch the order? Can I do that? Well, yeah, in this case, it doesn't really matter because that's a rectangle. In the next section, it's going to make a difference, but also the same idea. And put the x after and run from negative pi over 2 to 0. X cosine of x plus y. By doing this, with respect to x, with respect to y, this is a constant, so I just have to worry about that piece. And that's really one benefit of choosing dy over dx. So this integral first, x is a constant, the sine of x plus y, evaluated from y equals 0 to y equals pi over 2. So x is a constant, that's going to be the sine of, again, y, x plus pi over 2 minus the sine of x. And now I'm going to take this and I'm going to integrate that. Sometimes you could avoid an equation by parts. A lot of times you can't, but sometimes even you can't even integrate with respect to y first. So that's something you gotta look for. And here, I'm gonna let u equal x, du is dx, dv is the sine of x plus pi over 2, v would be the integral of that, that would be negative the cosine of x plus pi over 2. So this is going to be u times v minus the integral of v du, so that's going to be plus the sine of x plus pi over 2. And all of that is going to be evaluated from negative pi over 2 to 0. That's going to be, throw the 0 in, that's a 0 plus, the sine of pi over 2 is 1, the cosine of 0 is 1, minus, throw the negative pi over 2 in. Negative pi over 2 will make that a 0, so that's a 1, times negative pi over 2. Negative pi over 2, and that will make that a 0, that's a 0, and cosine of negative pi over 2 is a 0. Again, on a test, this is more than enough. For the back of the book, you're going to say 2 plus pi over 2. It makes no difference. Same thing. So again, techniques of integration are going to come up. some space there. Here we go. Sketch the volume. Well, let's see, what are they talking about? They're talking about 3 dimensions. We know how to graph z equal x squared plus y squared, something like this. I should have shifted that up 1 unit. What I'm going to do, I'm going to cut that between 0 and 1 and 0 and 1. So what that's going to do, I'm going to cut this kind of like, think of this umbrella, upside down umbrella, and you cut it with a straight edge. So it really doesn't look exactly like that here, I should say. If you cut it with a laser, actually it is going to look like that. Yeah. I'm looking for this volume. Right? So the volume really is differing depending where you are. The further you go from the origin, the higher this runs up to. And the closer you are to the origin, the smaller that is. So think of it again, upside down umbrella, and you go from the floor and you fill with water, but you're only looking in quadrant 1 or octant 1. That's kind of what you're looking at. And if I go for B, (3 minus x squared minus y squared), and again I'm going to cut it down, so this is supposed to come down, but I'm going to cut it at 0, 1 and at 0, 1. So this part is going to be flat, and this part I'm going to get right. So it's coming down. The top is really circular, but the bottom is really flat, and you're looking pretty much only in the first octant, and there it is. And you could tell where this point is when x equal 1, y equal 1, 1, 1, 1. And if I look at my last example, somewhere here, yep, but those are going to take a lot longer. Okay. Find the volume. This is really what we're going to do for the most part. 9 minus, so 9, let's say this is 9. And if I set z equal to 0, x would be 3 or negative 3. First octant. And this graph runs infinite. Except you're chopping that at 6. I'm looking for this volume, a quarter of a cylinder. Well, volume is going to equal, if I'm looking at this from the top, if I'm looking at this from the top down, volume is going to be the double integral, and I'm running top minus bottom. That's 9 minus y squared, no big secret. But if I'm looking from the top, this is all I see. I see x running from 0 to 6. And I see y running from 0 to 3. And this floor is the only thing that I want to find the area of. And how do you do that? Well, that's simple. You could say, let's run this way. I could say, let x run from 0 to 6. And that means y is going to run from 0 to 3. And you could integrate that and figure out the volume. That's really how it works. That is 9y minus y cubed evaluated from 0 to 3. That is 27 minus 27. Okay, what's going on? 9y minus 3y cubed over. I was getting 0. I was worried. Minus 9. 27 over 3. So this is actually 18. And now what I'm going to do, I'm going to integrate 18 from 0 to 6 with respect to x. That's 18x evaluated from 0 to 6. That's 18 times 6 minus 0. So what is that? 48, 108. There it is. And that's how this works. And that's pretty much it for this section.